In this video, we will start our discussion about systems of equations, specifically the linear equations in two variables. So let's first define what a system of equations is. A system of equations is simply two or more equations that are grouped together as one unit. For example, with the brace here, we see that we are combining these two equations together. So when we talk about a solution of a system, we're looking for an ordered pair that make both equations true. So if the ordered pair 5, 1, for example, makes both the first and second equation true, therefore it is a solution. So if you recall from the previous video, all the ordered pairs here make up one equation. And all the ordered pairs make up this equation, one equation. But if we graph them on the same plane, we can look for the point of intersection, and therefore this would be the solution to the system. Now, a system can be classified as three different ways depending on its solution. It can either be consistent and independent. The picture that is graphed on the side, this system would be consistent and independent because there's only one solution, namely the ordered pair right there. However, we could also have a consistent and dependent system. This is where we have infinitely many solutions. Note that it's not all real numbers. It is simply an infinite amount of ordered pairs because essentially, if we have a consistent and dependent system, this is the same line, which means that any solution that works in the first equation must also work in the second equation. And then there's the inconsistent. Simply means no solution. If we were to look at a graph of a no solution system or an inconsistent system, what type of lines would we have? Good question. Let's look. Oh, well, the answer is they're parallel lines. Now, if we have a system of equations, we have three different ways that we're going to look at solving them. We're going to talk about graphing, substitution, and elimination method. In this video, we're going to be focusing on graphing. In the next video, we'll talk about the other two methods. So how do we solve a system by graphing? We're going to graph each equation on the same coordinate plane. We'll find intersection points, if any. If there is one intersection point, then the solution is the intersection point. This means we have a consistent and independent system because there is one intersection point. There's one unique solution. Now, if we graph and we find that they actually are the same line, then what we have is infinitely many solutions, or we have a consistent and dependent system. The solution to this would be a solution set such as the solution would equal the ordered pairs x, y, such that, and then we'd write the equation of the system. So for example, if y equaled 2x plus 1, then what this tells me is that any ordered pair that makes this equation true would be the solution to the system. This only happens if you have an infinitely many, or if you have a consistent and dependent system. Now, if there's no intersection, then there's no solution. It is simply an inconsistent system. We would say the solution set is the empty set. This is where we would have parallel lines because there's literally no intersection. Here's a visualization. If the lines intersect at some point, then we have a consistent and independent system. If the lines are parallel, there is no solution, and we'd say this is inconsistent. And then finally, if they're actually the same equation, we have infinitely many solutions, and we're left with a consistent but dependent system. So depending on how the lines interact in graphing will determine its solution. Now, how do we actually graph a line? We're going to first determine the y-intercept and the slope. We could also do a different way by finding the two intercepts, the x-intercept and the y-intercept, but we'll talk about this one now. If we're in slope-intercept form, it's really easy to figure out the slope. The slope is simply the value in front of the x. And the y-intercept can be found by that secondary value of b. However, we can always find the y-intercept if we put in 0 for x. We will then plot the y-intercept, then we'll use the slope to find another point. Alternatively, we could find the y and x-intercept. And draw the line between them. So there's a couple different ways you can graph the lines. It just depends on which one you're more comfortable with. But notice that both of them involve finding at least a point on the graph, and then you can use the slope to find another. So let's practice. We're going to solve the system by graphing. The second equation here is listed as slope-intercept form. So from here, I know that my slope is -3 and that my y-intercept is 0, -5. So on the graph, I can plot the order pairs 0, -5, and then use a slope of -3, which from slope is the same as -3/1, to find another point. I'll go ahead and draw this blue line. Now I'm going to have a scale of 1 for my grid. So every grid line is going to represent a unit of 1. So I'm going to plot 0, -5. So 1, 2, 3, 4, 5. Plot it right there. Okay. Now I'm going to use a slope of -3/1 to find another point. If I go down 1, 2, 3, and then over 1. Oh. And then I can also go up 3 and over 1. And 3 over 1. So now what I can do is I can draw this line of 3 over 1. It's just really hard to do on a computer. Ooh, that was a bad one. That should be up here. And then 3 over 1. Okay. So I agree. Oh no, this is supposed to be here. Oh my goodness. This is the one thing I was fearing doing this on a computer. All right. 1, 2, 3. 1, 2, 3. All right, so now I can draw a line as best as I can. Oh, okay. Now, hopefully on your paper and in class, I'll be able to do much straighter. So let's look at the second one. The second one's a little trickier to find. So what I'm going to do is I'm going to first find the y-intercept. In order to do that, I'm going to change my x, and I'm going to replace it with 0. Because if it's the y-intercept, then it's going to cross the y-axis, and therefore my value of x will be 0. So I'm going to get -2y equals 4, therefore y equals -2. So this tells me that for my first problem, I have a y-intercept of 0, -2. I'll go ahead and use green. So 0, -2, it's going to be right here. Okay, but now I have to find another point, or I need to find the slope. In this form, it's easier to find the x-intercept than to put it in slope form. So this one, I'm going to let x stay the same, but I'm going to let y be 0. Solving this, I'm going to get x equals 4/3. So because I don't have an accurate a more precise scale, we'll say that we have a more precise scale, I'm going to go ahead and just estimate. So that would be like right around here somewhere. Now I can draw my line. Somewhere around here. Now again, this line is not going to be as accurate as the blue line because I didn't use the slope. I used just 2 ordered pairs to find it. But in either case, we find that there's an intersection point. Now, because my lines are not as accurate, we can only estimate what this is. And based on this, it looks like it's closer to -1, comma, negative 1, 2, 1, 2, 3.5. Okay. So based on my drawing, that's what it looks like. I will tell you that the actual solution is -2/3, -3. That's the actual solution. Now when you are graphing on paper, it'll be much more easier to be more accurate or precise in your lines. But again, if you're graphing your lines incorrectly in class, but you still point out the correct solution or the placement of the solution, I am going to give you credit for that. We'll do more practice in class about graphing, and then we'll move on to the other 2 methods.